Hello everyone. Today we will talk about projectile motion. Before we begin, we must answer a very important question. What is a projectile? A projectile is basically an object that moves in a curved path under the influence of gravity only. However, in real-life applications, it's not sufficient to only consider the weight of the object. Therefore, we will study the projectile motion taking into consideration air resistance as well. Sir Isaac Newton's three laws of motion greatly increased our understanding for projectile motion and the main forces affecting the object. Moreover, Gustav Magnus discovered what was later named after him, the Magnus effect, which explained how a projectile can change its course mid-flight without any external interactions. We start with the main three forces affecting a projectile in motion. First, the weight of the object acting down towards the center of the Earth. Second, drag force due to air resistance acting opposite to the direction of motion. Third, lift produced on a spherical projectile due to spinning, which can dramatically change its path in more than one direction simultaneously. Deriving the equations, we state the assumptions made to facilitate the derivation and the solution. A constant Reynolds number to keep the flow from separating. The flow is also assumed laminar everywhere. We will also assume the projectile is a perfect sphere of a certain radius. The air is assumed incompressible with constant density. Also, standard sea level conditions will be used for the upcoming calculations. We start the derivation with Newton's second law of motion, expressing the forces acting on the projectile. The first term is the effect of gravity, the second is Magnus force, and the third is for the drag force. Solving for the acceleration, we get the following equation. To solve the previous equation, we must choose one of two ways, analytical solution or numerical solution. The analytical method will give us the following equations. These equations are called coupled equations. Coupled equations have variables that depend on each other, and so a change in one variable will constitute a change in all the other variables. The result is a set of equations that are difficult to solve. The solution is then the best choice. Using the numerical approach, we arrive at the following two relations, the first for velocity calculations, and the second for calculating the position. The applications of projectiles motion then. The applications are limitless, however, here we will discuss the application of projectiles motion in sport. We start with a simple tennis ball. A topspin shot will give the ball a negative lift, pushing the ball down. The result is that the ball can make a rapid descent after a high flight. Another technique is the backspin, where we spin the ball in the opposite direction, which will result in a positive lift keeping the ball over the net. The result is that the ball takes longer to reach the opponent, providing the defender more time to get back to position. These techniques are also used in football as well. We take a look at what is called side spin, where the ball has lift force acting on one of its sides. The result is what we see here. The ball is initially kicked to the right to clear the wall of players, then the lift acting on it pushes it back towards the goal again. Golf, however, to produce spin we have to take into consideration the tools used and the friction coefficient. Here we see how backspin is induced into the ball and its effect on its trajectory. Notice how the backspin gets the ball to travel a longer distance than a normal shot. The last question we need to answer is, what if we didn't consider the air resistance? Using the script we developed, we compare between the trajectory of a projectile with and without air resistance. Although it seems at first glance air resistance has a negative effect, we have seen earlier how we can use that to our advantage to manipulate the path of the projectile. We hope you found this video useful. Please don't hesitate to contact us if you have any questions. Have a nice day.